Hello everyone, welcome back to this lecture. In this lecture, I will discuss about the class-based decorator. In previous lecture, I discussed more about function func tool. Let's recap. Uh, functool.wrap they try to preserving the original metadata of a original function. For example, name of the original function, docstring of a original function, annotation of a original function, and so on. So their main function is to preserving the metadata of a original function. That's why we use the functool.wraps. So that is used in various ways like to testing a framework. They rely on the function name for documentation and debugging and many more. So their main work is to preserving the metadata of a original function. In this lecture, I will discuss more about a new topic that is class-based decorator. We have studied what is class and object. We also apply in a decorator case. So till this lecture, uh, we have seen the function-based decorator, but in this lecture, I will discuss class-based decorator. Why do we need to study or why do we use the class-based decorator? What are the difficulties or limitations are there in a function-based decorator? So Python also allow a decorator to be created using class by leveraging the special call method. Okay, as we know, we have a call method and it will be called whenever we call the original function. Okay, it is the same structure as we study the class. They have a constructor where we define the function and we have a call method that is a special type of method. And so why should we use the class as a decorator? First of all, that is the most important thing, that is state. To maintaining the state between the multiple calls. Suppose you write a class-based decorator, you have a original function. You decorate the original function with the class-based decorator. If you using a class-based decorator, you maintaining the state. It means if you call the multiple times your original function, it maintaining the state. It will preserve it having a some state. But if you don't use the class-based decorator, instead you use the function-based decorator, it will not have a state. It will not have a some type of memory. I can say in simple term. So, decorator, wherever you need some logic, initialization logic, you should use the class-based decorator, and it follow or adhere to the OPS principle. Okay, so that is the key point you have to remember. That point I will show you when I write a code. And let's talk about when to use like class-based or function-based decorator. We have a three scenario. I take simple wrapping, to store state, or to call counting and timing. If you are doing simple wrapping, it means you are making a decorator and you just write a simple wrapping function to decorate the original function. So you must go for the function based decorator. That is enough for dealing with that problem. But class based, don't go for class based. You can use a function based. If you want to preserving the state, so you should use the class based decorator because it it has some inherent properties to preserving to having a memory or state. But function based, if you use a function based to having some state or memory, it become too difficult to manage it. That's why we must use the class based decorator. For example, like if you want to counting how many times your function is called, so this can be done via class based in easy manner. But function based, it can be done, but it become a very difficult to manage it. That's why we must go for a class based. So simple thing is there. Whenever you are writing a decorator, if it is simple, you must use the function based. If it is become very complex, so you must go for the class based decorator. So let's move to the VS Code where I will write a code and explaining how class-based decorator are defined and how it is used or how it is different from the function-based decorator. Okay, let's move to the VS Code. Yeah, first zoom in. Okay, let's create the new file class-based decorator decor.py. Okay, so here first I will create the class based decorator, use the class keyword. I'm mentioning the name decorator, and after that I have to initialize the constructor. Then I will write self dot func call func define call self, and here we can pass the argument arbitrary arguments, and we can also pass the keyword arguments. Okay, here I mention okay, I mention keyword. Then I will write the logic here. First, like I printing some, like I write here before. Okay, just simple. And after that, I am calling the function self dot func, and here I am passing the same arguments and keyword arguments. Okay, then here I writing like after this function, here I will returning the result. Okay, so that is a decorator I made. That is a class based decorator. And next I will create a simple original function that we want to decorate it with some decorator. I write here print hello. Then let's I write the principle remains same for a class based and function based decorator. You have to use the at and my decorator. Okay, okay, I write it wrong name. Yeah, done. So let's run, say hello. First I will run and see what output you will get. So here what happened, uh, this say hello function, I write a original function say hello, and this is our decorator. So Python see the this decorator. Python see this decorator, and it create the instance of this decorator. Instance nothing but object of this class. So we created the instance of the my decorator class, and it passed the after creating the instance, it passed the say hello as a function here. Say hello, and this is initialize here self.func, and that instance is become a callable. That instance become a callable because we use the special method that is called call. Call method we used, that become a callable, and when you call this function, it means you are calling a instance. You're calling an instance. It means you're calling this call. Okay. So let's repeat again. Uh, like you have written this, and this is your decorator, class-based decorator. And when Python see this decorator that is class-based, so it create the instance of this decorator, instance of this class that is my decorator. After creating the instance, this say hello function is passed and become a self.func. Or this instance is callable because we are using a underscore underscore call underscore underscore. Whenever you call say hello, it means you are calling the instance that is no this one. That's why we are getting a before, hello, and after. Okay, that is a main use case. Let's like I take one more example to show you some. Like I write here self dot count. I will show you how you can manage the state. It means you are some preserving the having some kind of memory, not a memory. You can think like memory. And here I will pass self dot count. It means whenever how many you call the function again, it will be count. It means preserve the state in the same environment. Okay, so let's run, and I remove this, and let's I write function called here I'm writing f string. Here I am passing self dot count. Here I'm passing times. Okay, so let's first I create only one function, hello function called one time. Okay, let's I create this again. So you will see hello function called one time, and function called two time. Okay, called two times. So it means it preserving the state. It is preserving the state. We can initialize, we can write our logic in a init constructor. Okay, that is the advantage of using a class-based decorator. If you are making a very complex decorator, so you must use the class-based decorator, because if you use the function-based decorator, it become a difficult to manage the state, and it become very ambiguous to managing the things. So that's why we must go for class-based decorator. I think you got how it is working. Python see this decorator, and the instance of this class or decorator created, and in this instance we pass the function is passed say hello, and this instance callable because we are using a underscore underscore call underscore underscore. Whenever you call this say hello, it means instance is called. Okay, so that is a class-based decorator that is mainly used when you are building a complex decorator, and you want to maintaining the states between the different calling of a original function. Thank you so much, everyone. See you in next lecture.